Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you header length and checksum of TCP segment header. If you observe, we are having TCP segment header over here. This is complete TCP segment header. In that, I'll explain you how we have header length, that is also referred as data offset, as well as I'll explain you how checksum is there in this video. If you have seen my last videos, in that I have explained you how we can have wraparound time, how we can have sequence number, acknowledgement number, as well as I have explained you how we can have port addressing in source and destination, right? That I have explained you in my last 3 videos. In this video, I'll explain you how we can have header length and checksum. In some books, you will be observing this data offset field that is represented as header length. See, size of this data offset field that is having size of 4 bits. You can observe here 1, 2, 3, 4. 4-bit size that is there with data offset. Now, you need to understand first how this data offset that is getting calculated. See, data offset means header length. So, header length of this TCP segment that is getting computed by this 4 bits only. If you observe this header of TCP, then in that you see there are some mandatory fields. Those are compulsory. Like you see source port and destination port. So that is compulsory. That is having size of 2 bytes and 2 bytes, in total 4 bytes. Then sequence number is there, that is having size of 4 bytes. Then acknowledgement number is there, that is having size of 4 bytes. Then you see this all fields that is having in total size of 4 bytes. Then checksum and urgent pointer that is having size of 4 bytes. So in total, if you observe here, 4 plus 4 plus 4 plus 4 plus 4, 20 bytes, those are mandatory. So maximum size is 60 byte, but minimum size means mandatory field that is having size of 20 bytes. So as and when you have minimum size of header over here, at that time, it will be having size of 20 bytes, and in that situation, this data offset that will be 0101 means it will be 5. Now how it is 5? You see header length that is 4 into binary value of data offset. So this is what 5. 5 into 4 that is 20. So always remember header length that is always there in terms of super multiple of 4. Header length that is always there in terms of super multiple of 4. Whenever you have minimum size of header, at that time it will be 20 byte. In that situation, this offset value, offset value that will be 0101 means it is 5. This is minimum value, right? Those 4 bits that will be 0101. So it will be 5. What it means? Minimum header length that is given over here. Now as if maximum header length that you want to calculate, then how it is maximum by 60 bytes? It is maximum by 60 bytes as per maximum value of data offset, that could be all ones. 1, 1, 1, 1. That could be all ones, right? If it is 1, 1, 1, 1, then it will be 15. 15 into 4, that will be 60. So maximum header length that will be of 60 bytes. Now here there is one more interesting concept that you need to understand. See, this is mandatory field. This is mandatory field, right? But if you observe here, we are having optional field that is options over here. And these options can be having size of at max 40 bytes. 60 minus 20 at max 40 bytes. But how it is getting computed? Let me explain you that. See, for that, if I say here, let us say we are having mandatory field that is 20 byte. Plus if I say we are having 6 byte of option over here. So that makes what? 26 byte. That makes what? 26 byte. But 26 cannot be represented as per data offset over here. It should be always super multiple of 4. So you will have to choose 28 instead of 26. So here plus 2 byte that we will have to add over here to make it to 28 bytes, which gives you header length, right? So what is this? What is this 2 byte? This 2 bytes will be padded as per all zeros, right? This 2 bytes that is additionally padded along with this option with all zeros. So header length that is getting computed as per 4 into binary value of this data offset minimum header length is 20 byte. In that situation, this data offset will be 0101 means 5. So 5 into 4, that is 20. Maximum will be 60. As per this is what 1111, that is 15. 15 into 4, that will make it to 60 bytes. But as and when you have option field which is having some value, in that case you will have to do additional padding. As if it is 6 byte, in that case total will be 26, but you cannot have 26 bytes. You will have to have super multiple of 4. So you will have to add additional 2 bytes, which will make it to 28. For 28 representation, here there will be 0111, right? That is how data offset, or you can say header length, that is there with us. Now second interesting concept that I am going to explain you, that is checksum. This is very interesting and essential. See, first of all, you need to understand how checksum is getting computed. See, checksum that is getting computed on 3 fields. One is TCP header, second is TCP data plus pseudo header. Checksum calculation that is happening on TCP header, TCP data and pseudo header. See, here we are having IP packet. Here we are having IP packet. In IP packet, this is IP header and this is IP data. Now inside IP data, we have TCP segment. So with TCP segment, again we have TCP header and TCP data. So you see TCP header, that is this, then TCP data, that is this, and pseudo header is there. And pseudo header, that is taking fields from IP header. So first of all, you need to understand how it is getting calculated. Let me explain you that first. After that, I'll explain you how pseudo header is there. See, it will take these 3 fields first. TCP header, that is this, then TCP data and then pseudo header. Right now consider pseudo header that is there with us. Now by taking this field, by taking this 3 field, it will be computing checksum. But in that, if you observe here, inside TCP header we are having checksum. You see, inside this TCP header we are having checksum. So first of all, what it does is it will place this 16 bits as all zeros. So this 16 zeros will be there over here first. So it will be keeping checksum as zeros first, then it will be taking TCP header, then it will be taking TCP data, then it will be taking pseudo header, it will compute checksum and it will place it over here, right? That is how it will compute it. So first it will be considering checksum data that has all zeros, those 16 bits, that will be all zeros first. After that, it will compute checksum by considering these 3 fields. Now question is, what is pseudo header? See, pseudo header that is having fields which is taken from IP header. If you have seen my last videos based on IPv4, in which I have explained you, in IP header we have source IP that is having 32 bits, we have destination IP that is having 32 bits, then we are taking 8 bits, those are reserved and which are zeros first, then we are taking protocol field from IP header only, and then TCP segment length that we are computing first, that is having size of 16 bits. So you see 4 plus 4 plus 4, in total 12 bytes are there. Those 12 bytes are pseudo header first, right? It will be taking those 4 bytes first, and that it takes it from IP header. It will borrow it from IP header. And then it will take TCP header and TCP data. Based on that, it will perform CRC, and based on CRC, it will compute checksum by placing zeros over here in TCP header, and once it compute it, it will place it over here inside checksum field of TCP header. See, this is how complete calculation that is happening with checksum. Now there can be question like, why should we calculate checksum 2 times? If you have observed IPv4, in IPv4 we were been already having checksum inside IP header. If you have seen that calculation of checksum, then you will be having idea about, like, see, this checksum of IP header that was based on IP header only. Now whatever checksum that we calculate over here with TCP header, that is based on TCP header, TCP data, as well as this pseudo field which is computed from IP header. So here we are having 2 times calculation of checksum with complete packet, and that we are doing it to make sure our transmission is error free, right? So to have error free transmission, checksum that we are having 2 times, and See this checksum of TCP header that is getting computed like this. Checksum of IP header that already I have explained you in my videos based on IPv4. You just go through it. That will definitely gives you idea about how checksum is there with IP header. And here, if you observe this checksum 16-bit field, then initially it will be zeros over here before calculation. After calculation, whatever data that is there based on this checksum calculation, that we place it over here. That is how things are happening. Still, if anything that you like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.